Welcome to Golang for Devs. Let's talk about runes and strings. Okay, so in Go, strings are stored internally as a sequence of bytes, not characters. This is in contrast to languages like Python and Ruby, which store their strings as actual sequences of characters. And there are some tricky gotchas that come up because of this that I'll cover in this video. Strings in Go are also immutable, and they are considered reference types, meaning they hold a reference that points to the backing bytes in memory. But unlike all other reference types, you can't modify a string, so there's no risk of changing a string copy that gets passed into a function. So because of this, it's said that even though it's a reference type, strings have value type semantics in Go. By convention, strings in Go are UTF-8 encoded. There's ways to use other encodings, but don't worry about it unless you need to. Okay, let's get to some actual code. So you can create a string from a literal like this. And if you don't specify a value, Go will instantiate it as an empty string, which is the zero value for a string. One other thing you'll see a lot of in Go is using a byte slice to instantiate a string, because again, strings in Go are just a sequence of bytes. And if you don't know, a slice is just a reference type that points at a backing array. So here, I am reading bytes in from a file and then returning those bytes as a string. So those are strings. Now, what the heck are runes? To put it simply, runes are the same as characters in other languages, just with a fancier name. Internally, the rune type is just an alias for an int32, which is a 32-bit integer. 32 bits are used because that is the max size of a character in UTF-8 encoding. So you can create a rune from a rune literal with single quotes like this. And because it's just an alias for an int32, the zero value of a rune is just 0. Okay, let's get to some common operations using strings and runes. So you can find the length of a string using Go's built-in length function like this, which evaluates to 5 in this case. But one of the gotchas with strings is that the length function returns the number of bytes, not the number of characters or runes in the string. So if I have another string with an accented E in it, and I try to get the length of it, it'll actually be 6 instead of 5 because the E with an accent is a character that takes up 2 bytes in UTF-8 encoding. You can get around this by casting the string to a rune slice and then taking the length of the rune slice. So in this case, it'll give you the actual number of characters, which is 5. But keep in mind that using a rune slice is a little bit slower because it needs to walk the string and allocate a new slice into memory. So if you're only using 1 byte ASCII characters, then it's better to just use the length function on this string itself. Okay, you can compare strings in a few different ways. So if I have 2 strings, I can use regular comparison with equals equals, and that compares strings byte-wise, so it is case sensitive. The second way to do it is to use the compare function from the strings package in the standard library. And the compare function will return 0 if the strings are equal, 1 if S1 is greater than S2, and -1 if S1 is less than S2. The next way to compare strings is to use the equal folds method. So this is a little slower than using equals equals, but it's case insensitive. And then finally, you can use all of the other comparison operators like less than and greater than. Okay, next up is concatenating strings. So if I have 2 strings, I can concatenate those together using plus signs. But another gotcha with strings in Go is if you use plus signs to concatenate strings, the runtime will allocate a new string for each subsequent plus sign. So it's very inefficient if you take it to the extremes. So to get around that, you can use the strings.builder struct type from the strings package. And if you don't know, structs are similar to classes in other languages, and I'll hit them in a future video. Okay, so I have my builder, and the builder uses an internal buffer to avoid allocating over and over again. So you have to call grow on it first to make sure it has space for all the strings you want to put in. Next, you write each string, and then you actually build the string. So as a general rule, if you're concatenating more than 5 strings at once, you should use this builder type. Okay, how do we access an index in a string? So if we have the string hello, you can get the byte at a specific index using square bracket notation. So this would be L in this case. But you run into the same byte versus runes problem that you had before. So if I have another string with the accented E in it, which is 2 bytes long, and I try to get the character at index 1, I only get the byte from the first half of the accented E, which is just nonsense data. So again, the fix for this is to cast to a rune slice and then get the index you want. So that will actually return the accented E rune. Okay, next up is slicing out substrings. So if I have a string world and I want to get the WOR, I can do it with this syntax from 0 to 3. So the first number, the 0 in this case, is inclusive. So you start at that index. The second number is exclusive. So in this case, you would finish at index 2, which is the R. You can also drop the number on either side. So if I do from nothing to 3, that means it starts at 0. And if I do from 3 to the end, it starts at index 3 and finishes at the last index of the string. And again, if any of the characters are more than 1 byte long, you can get skewed results from this. So if I go from index 0 to index 3, I would be expecting HEL, but what I would actually get is HE because the accented E is 2 bytes long. And the fix again is just to use a rune slice instead of using the string directly. The last thing to note with slicing is that the new string will reference the same backing bytes as the old string. So there's no new allocations that happen. Okay, next up is string conversion. These functions are all built into the string convert package. So you can do an int to a string using I2A. You can parse a string into an int using A to I. And then there are a bunch of other functions in the package that you can use to interact with other types. And I'll link the docs to that package in the description. Okay, last tricky thing to talk about is string iteration. So there are 2 ways to iterate over a string. The first is using a regular for loop and accessing the current byte of the string using the index. So this way, iterates over the bytes of a string, not the characters. If you want to iterate over the actual characters or the runes in a string, you have to use a for range loop. So this will give you direct access to the runes, even if they are more than 1 byte in length in memory. There are plenty more functions in the strings package of the standard library that you can use to work with strings. There's stuff for trimming strings, for splitting and joining, for changing the case, for searching, and lots of other stuff. It's a fundamental part of the Go standard library, so it's definitely worth a read, and I'll link those docs in the description. And that is all you need to start working with strings effectively in Go. Thanks for watching, and if you found this helpful, shoot a like, give it a subscribe. Until next time, keep breathing, keep building. Peace out.